Imagine looking at a baby, but that baby already has a PhD, doesn't make sense, right? Now imagine astronomers looking at a baby galaxy, one that existed when the universe was only 300 million years old, and finding that it was already chemically mature. It's a complete shock. In March 2025, a stunning announcement shook the scientific community. Astronomers had detected oxygen in Jades, JWST the most distant galaxy ever discovered. This wasn't just a fascinating observation, it was a cosmic conundrum. How could a galaxy so young already possess so many heavy elements? The answer challenges our very understanding of the cosmic timeline. Let's set the scene, the cosmic dawn. After the Big Bang, the universe was a far simpler place. It was almost entirely made up of the lightest elements, hydrogen and helium. There were no galaxies, no planets, and absolutely no elements like carbon, iron, or oxygen. Over millions of years, gravity began to pull these simple gases together, eventually igniting the universe's first stars. These were the mythical population 3 stars, massive, brilliant, and short-lived. They were the universe's first alchemists, burning with incredible intensity, forging heavier elements in their cores through nuclear fusion. But this process was thought to be a slow burn. Only through the death of these stars, in powerful supernova explosions, could those heavier elements be released back into space. This seeded the next generation of stars, which would contain more metals, and so on. Scientists theorized that it would take hundreds of millions of years, even a billion, for galaxies to become sufficiently enriched with these heavy elements. In the early universe, we expected to find chemically immature galaxies, still building their elemental inventory. Our investigation into the cosmic past got a massive upgrade with 2 of humanity's greatest scientific instruments. The first is the James Webb Space Telescope, or JWST. JWST acts like a time machine, its infrared eyes peering through the vast cosmic expansion to see galaxies as they were billions of years ago. It was the JADES program on JWST that first spotted jades, JWST The extreme redshift of the galaxy's light revealed its incredible distance, placing it just 300 million years after the Big Bang. But JWST could only give us a blurry fingerprint of its chemical makeup. We needed a different tool for a closer look. That's where ALMA comes in. This massive network of radio antennas on a high-altitude plateau in Chile is perfect for detecting specific chemical signatures. Light from distant objects is stretched by the expansion of the universe, and ALMA is sensitive enough to pick up these stretched radio waves. 2 separate teams used ALMA to follow up on the JWST observation. By analyzing the spectrum of light, they looked for a telltale fingerprint, a specific emission line at a wavelength of 88 micrometers. And there it was, a clear, undeniable signal of oxygen. This detection was so precise it even improved JWST's initial distance estimate by a factor of 200, confirming its status as the most distant and oldest oxygen detection ever made. The presence of so much oxygen in such a young galaxy has sent shockwaves through the astrophysics community. The amount of heavy elements, or metals, was about 10 times higher than standard models predicted. In the words of astronomer Sander Schaus, it's like finding an adolescent where you would only expect babies. This implies a much faster evolutionary track for this galaxy. It means JADES, JWST didn't just appear early, it grew up quickly. It must have had multiple generations of stars that formed, lived, and died in a fraction of the time we thought possible. This forces us to ask new, fundamental questions. Were the very first galaxies fueled by unusually rapid bursts of star formation? Did the initial population of stars skew heavily towards the massive, explosive type, accelerating the production of heavy elements? Or perhaps, did the vast, primordial gas clouds collapse more efficiently and earlier than our simulations suggested? This single finding has a massive ripple effect throughout cosmology. It forces us to reevaluate our understanding of everything from the nature of the first stars to the formation of the elements that make up our world. For instance, we know that oxygen is produced through a nuclear process in stars called the CNO cycle. Detecting oxygen so early and in such quantity means the conditions for more advanced stellar processes and chemistry were present much sooner. And while purely speculative, this also opens up intriguing possibilities for astrobiology. Heavy elements like oxygen are the building blocks for planets. If these elements were abundant so much earlier, could the basic ingredients for life have been around sooner? Finally, this discovery is a perfect example of what a new era of astronomical tools can achieve. JWST gives us the deep vision, allowing us to see these faint, distant objects. ALMA gives us the spectroscopic precision, allowing us to perform chemical analysis across billions of light-years. Together, they are rewriting cosmic history, one ancient galaxy at a time. JADES, GS Z14-0 is a powerful reminder that the universe is full of surprises. It challenges our neat timelines and pushes us to reconsider our fundamental assumptions. What other mysteries are waiting to be uncovered in the first few moments of cosmic history? We have the tools to find out. If you want to dig deeper into the incredible science behind this discovery, check out the links in the description. What are your thoughts on this finding? Let me know in the comments below. And if you enjoyed this cosmic deep dive, don't forget to like and subscribe for more. Thanks for watching.